This is my third lecture video on the topic of critical values and extrema. In the first video, I defined what a critical value was, and we did some examples of finding critical values. In the second video, we talked about relative or local extrema and how we use critical values to find those extrema. And now in this video, we're going to be talking about absolute extrema and how we can use critical values to find those as well. So absolute extrema are the absolute highest or lowest points on a graph. The absolute highest or lowest, not relative to a certain area, but the absolute highest or lowest. So here we have a point on the graph, which is clearly a relative extrema because it is the lowest point on this graph in this relatively small area, but it is also the absolute smallest point or lowest point on the graph. So therefore, it is a relative extrema, but it is also an absolute extrema. It is an absolute and a relative minimum point. It can be both. So let's take a look at an example like this. And we have a graph that starts at point A and ends at point B. And so we have a relative maximum right here, and we have a relative minimum right here. But we also have point A, which is an absolute maximum. Okay? Even though this point right here is a relatively low area for this point on the graph, point A is the absolute minimum. And likewise, even though we have a relative maximum here, point B is the absolute maximum. So an absolute maximum or minimum point can be the same as the relative maximum or minimum, but it doesn't necessarily have to be. Let's take a look at the second example of an absolute maximum. So here we have absolute maximum and absolute maximum, which are also relative maximums. Okay, so these are both relative and absolute maximum points. And we also happen to have a relative minimum here. That is a relative minimum. But what about the absolute minimum? There is no absolute minimum because if you take a look right here and right here, you see that there are little arrows on the end of these, which means they're going down infinitely far, they never end. So there is no absolute minimum. No absolute minimum point. So to sum all this up, finding absolute extrema. Absolute extrema, if they exist, will occur either at critical points or end points, as we've seen in these last two examples. So this is different than relative extrema. Relative extrema will occur at critical values. Relative extrema at critical values, but absolute extrema could be at critical values or at endpoints. Just to drive home this point, let's just do one more example. So here we have another graph with a couple twists and turns in it, and it goes from point A to point B. And right here, we have a relative maximum. And right here, we have a relative minimum. Now, what is the absolute maximum? Well, the absolute maximum is also right here. There is no higher point on this graph than at the relative maximum. So the absolute maximum is the same as the relative maximum, which means that it is at a critical value. But what about the absolute minimum? The absolute minimum is down here at an endpoint. This is an endpoint. This is an endpoint. And this endpoint is the absolute minimum. So in this case, the absolute minimum occurs at an endpoint. The absolute maximum occurs at a critical value. All right, so let's do a couple of examples. The first example, find the absolute extrema of the function x squared minus 2x over the interval from 0 to 4. So the first thing we want to do is find the critical values. Find the critical values. We already know what the endpoints are. The endpoints are 0 and 4. So we want to find the critical values. So that means finding the derivative. So that's going to be 2x minus 2. There's no place where the derivative is undefined, so we set it equal to 0, and we get x is equal to 1. So we have one critical value at x equals 1. So that means that we are going to have either a relative max or a relative min at that point. Now the question is that also where the absolute max or min is? Now to find the absolute max and min, what we're going to do is we're going to create a table, a t-table or a table of values. And on this table, we are going to put the endpoints and the critical values. So we have the endpoints 0 and 4, and we have the critical values of 1. And I'm going to put them in order. They don't have to be in order, but I like to put them in order. And so when x is equal to 0, we want to find out what the function value is. Remember, the function value is equal to the y value, which tells us how high the graph is on the y-axis, tells us how high or low it is. So going back to our function here, we have f of 0 would be 0 squared minus 2 times 0, which is 0. So this gives us the point 0, 0. When x is equal to 1, we're finding the function value of 1. So we have 1 squared minus 2 times 1, which is negative 1. And when x is equal to 4, we have f of 4 is equal to 4 squared minus 2 times 4, which is 16 minus 8, which is 8. So what we're looking for is the absolute highest and lowest point of these. So we have the endpoints, right? This is the endpoint, and this is the endpoint, and we have the critical value. So remember, the absolute extrema, the highest or lowest point on the graph, will occur at one of these three places, nowhere else. So what is the absolute minimum? It is the lowest point on the graph, which is negative 1. There we have our absolute minimum. And the absolute maximum would be the highest point on the graph, which is right here at 4, 8, which is the absolute maximum point. Okay, and that's because this is the largest y value. This is the smallest y value. And that's how we find the absolute extrema. Let's do one more example. We have x cubed minus 12x on the interval from negative 4 to 4. So first of all, let's find the critical values. And so the critical values are going to be 3x squared minus 12. There's no place where the first derivative is undefined, so we set it equal to 0. We have 3x squared equals 12. X squared equals 4. So x equals plus or minus 2. We have two critical values. Two critical values. At these points, we have either relative maximums or relative minimums. The question is, will we have an absolute maximum at one of these points or at the endpoints? So we're going to create a table, and we're going to put all of these points on that table. So we're going to start with negative 4, then negative 2, then positive 2, then positive 4. So that accounts for my endpoints, and it accounts for my critical values, are all on the table. And so now let's just evaluate each one of these in the function. So we have f of negative 4 is going to be negative 4 cubed minus 12 times negative 4. Negative 4 cubed is what? Negative 64. And negative 4 times negative 12 is a positive 48. So that is negative 16. And at negative 2, we have f of negative 2 is negative 2 cubed minus 12 times negative 2. Negative 2 cubed is negative 8. Negative 12 times a negative 2 is positive 24. So this is positive 16. 2, evaluating this at 2, we have 2 cubed minus 12 times 2. 2 cubed is 8 minus 24 is a negative 16. And then 4, we have f of 4 is 4 cubed minus 12 times 4. 4 cubed is 64 minus 48 is positive 16. So we're looking for the highest and the lowest y values. Well, the highest y value, we have two of them. They tie, 16. So we have 2 points where we have an absolute maximum. We have an absolute maximum here and here. Both of those are exactly the same height. Absolute max and an absolute max. So notice that one of the absolute maximums occurs at a critical value, and the other absolute maximum occurs at an endpoint. Now, the absolute minimums here, we also have a tie. And so we have, this is an absolute minimum, and this is also an absolute minimum. And one of the absolute minimums occurs at a critical value, and the other absolute minimum occurs at an endpoint. And so that is how you find absolute extrema.